the silent vault of space, a golden eye stares into eternity. It peers past the stars we know, past the galaxies we've charted, into a realm where the first light of creation still flickers in the darkness. Each beam it catches is older than our world, older than the sun, a fragile thread woven into the fabric of time itself. But lately, these threads have carried whispers of something impossible. Galaxies too ancient, too massive, appearing in the universe's infancy like great cities rising overnight in a newborn world. What the James Webb Space Telescope has seen does not just stretch our imagination. It bends the very laws of physics we believed unshakable. It is as if the universe is revealing a hidden draft of its own history, one written in symbols we are only beginning to decipher. Forces we thought we understood, gravity, light, the birth of stars, now seem to move to a rhythm we cannot yet hear. Tonight, we follow Webb's gaze into that uncharted past. We will walk the edge between certainty and wonder, and glimpse a cosmos far stranger and far more beautiful than we ever dared to dream. Imagine staring into the abyss of deep space and watching the known laws of reality begin to bend. Somewhere in that silent void, the James Webb Space Telescope has captured something so strange, so exquisitely impossible, that scientists are whispering about rewriting the very foundations of physics. Not an anomaly to be explained away, but a signal, a cosmic message that the universe is far stranger than we dared believe. In the darkness between galaxies, a truth older than time may be stirring. The Webb's golden mirrors sweep their gaze across an expanse untouched by human eyes, pulling back the curtain on epochs we thought we understood. It was supposed to confirm our models, to sharpen the details of the cosmic story already written. Instead, it has sent cracks racing through the narrative, revealing glimpses of structures, forces, or particles that seem to defy the rules forged in centuries of human thought. In the cold silence of its orbit, Webb has become less an observer and more a herald, carrying news from the edge of comprehension. Every photon it catches is a messenger from the ancient past, traveling billions of years to reach us. Yet, some of these messengers bear impossible tales. Galaxies too massive for their age, patterns in light that shouldn't exist, whispers of physics unaccounted for. As the data pours in, the question grows louder. Are we staring at a flaw in our instruments, or the first hints of a universe playing by rules we have yet to learn? To grasp the magnitude of this, we must step back and see where Webb is truly looking. Its vision pierces into a time when the first stars were newborn embers, and galaxies were mere smudges in the cosmic dawn. This is the epoch when gravity was sculpting the universe's earliest architecture, a time so far removed that the light from it has stretched into the deep infrared. No other telescope has seen so far, or with such exquisite clarity. Yet, in this distant light, Webb is finding fully formed, massive galaxies existing just a few 100 million years after the Big Bang. A feat our current physics says should be impossible. These galaxies are not the faint, struggling systems theory predicted. They shine with the weight of billions of suns, as though the universe skipped whole chapters in its growth. According to our models, such titans should require vast spans of time to assemble, with countless collisions and mergers over billions of years. But here they are, towering in the young cosmos like ancient giants in a nursery. Each one is a direct challenge to the timelines and processes we have etched into our understanding of cosmic evolution. And it's not just the size. It's the patterns in their light. Webb's instruments capture spectral fingerprints that reveal their chemical makeup and some carry elements forged in generations of stars, suggesting that they've lived and died in cycles far faster than we thought possible. The cosmos, it seems, may have been busier, faster, and far more inventive in its youth than we have ever imagined. To understand how such a revelation is even possible, we must peer into the hidden machinery of the universe, the fundamental laws that guide matter, energy, and time itself. Physics, as we know it, is built upon pillars: gravity shaping the grand structures, nuclear fusion powering the stars, quantum rules orchestrating the subatomic. These pillars have held for centuries, tested against everything from planetary motion to particle accelerators. Yet Webb's discoveries suggest there may be an unaccounted force, a missing note in the cosmic symphony, quietly altering the tempo of creation. One possibility is that our understanding of dark matter, the invisible scaffolding of the cosmos, is incomplete. If dark matter behaved differently in the early universe, clumping together more quickly, or interacting with normal matter in ways we haven't yet observed, it could have accelerated the birth of galaxies. Another possibility points to dark energy, the mysterious force driving cosmic expansion, whose properties may have shifted in the universe's infancy. Both ideas would mean the very constants we believe unchanging might have once danced to a different rhythm, but the mystery may run deeper still. Some physicists whisper of entirely new physics, particles beyond the standard model, or forces we've never detected, shaping the infant cosmos. Such ideas, though bold, have precedent in science's history. Every leap forward, from Newton to Einstein, began with observations that refused to fit the rules of the day. Webb may now be handing us the next such puzzle, its golden mirrors reflecting not just the past, but the future of our understanding. To glimpse the extremes of this mystery, imagine a galaxy so massive and so old that, by our current reckoning, it shouldn't exist at all, and yet it shines in Webb's gaze like a defiant beacon. In one observation, astronomers found a compact, brilliant system whose light began its journey when the universe was less than 350 million years old. By every model we possess, there simply wasn't enough time for that much matter to gather, ignite, and mature into a fully fledged galaxy. It is as though you found a towering oak in a meadow just days after planting the acorn. In another case, Webb revealed patterns of starlight, indicating generations of supernovae had already come and gone within this impossibly young era. Heavy elements, the kind forged only in the fiery deaths of massive stars, were already abundant. This means entire cycles of birth, death, and rebirth occurred in cosmic instants, compressing what we thought took billions of years into mere hundreds of millions. The universe, it seems, was an impatient architect in its earliest days. These are not gentle challenges to our understanding. They are seismic shocks. Each such discovery is like a chisel striking at the foundation stones of modern cosmology. If these galaxies truly formed so quickly and so richly, the rules governing time, matter, and growth in the young universe must be rewritten. Webb isn't just showing us the impossible, it's demanding that we redefine what possible means. History tells us that moments like this are rare, but when they arrive, they reshape everything. In the early 20th century, Edwin Hubble's revelation that the universe was expanding shattered the static cosmos of Einstein's first equations. Decades later, the discovery of cosmic microwave background radiation confirmed the Big Bang theory, transforming speculation into certainty. Each time, the evidence was undeniable, and the consequences rippled through physics, astronomy, and philosophy alike. Now, Webb's revelations may stand alongside those milestones, marking the dawn of a new chapter in our cosmic story. Scientists across the globe are poring over the data, testing it against every conceivable explanation. Could these be illusions born of gravitational lensing, where massive objects bend and magnify the light from distant galaxies, making them appear larger and older than they are? Or could our estimates of cosmic expansion, and thus time itself, be subtly wrong? Each hypothesis is being dissected, simulated, and challenged, yet many still leave the mystery unsolved. The more the data is tested, the more stubborn it seems to become. And this is the true hallmark of a paradigm shift, when the universe refuses to bend to our rules, forcing us to bend our rules to the universe. Just as Hubble's telescope expanded our vision a century ago, Webb is not only extending our reach into the past, but also revealing the cracks in the framework that holds our understanding together. Somewhere in those cracks lies the truth, a truth that could rewrite the laws of physics forever. For those studying the cosmos, there is both exhilaration and unease in this moment. Exhilaration, because we may be standing on the brink of a discovery that will propel physics into a new age. Unease, because such discoveries demand that we dismantle ideas we have built careers, theories, and entire institutions upon. In conference halls and late-night video calls, astronomers debate the implications, some cautious, others daring, a few openly admitting that their equations no longer feel trustworthy. The Webb's images are not just data, they are a challenge issued to every physicist alive. In laboratories, theorists are sketching bold new models. Some imagine that the speed of light or the strength of gravity may have been subtly different in the infant cosmos, altering the pace of galaxy formation. Others propose a primordial burst of exotic matter, particles that decayed too quickly to survive, yet long enough to sculpt the young universe in unforeseen ways. Even the nature of time itself is being questioned. Could it have flowed differently in those first moments, giving matter more opportunities to gather than our clocks would suggest? Whatever the answer, it will not come easily. Just as Darwin's theory faced decades of resistance and quantum mechanics upended classical certainty, the truths revealed by Webb will be hard-won, forged in the crucible of skepticism and evidence. But in that struggle lies the essence of science, to follow the trail of truth, even when it leads us into the dark, uncharted corridors of the unknown. For the rest of us, far from observatories and data streams, the Webb's revelations carry a more intimate weight. They remind us that the universe is not a fixed, predictable machine, but a living, evolving mystery. Every photograph it sends back is a time capsule, a fragment of an era so remote that the Earth itself did not yet exist. To look at those ancient galaxies is to see not only the past of the cosmos, but the prelude to our own story, a reminder that everything we are was once stardust scattered in the same primeval seas. Technologies born from the pursuit of such cosmic questions often ripple back into our daily lives. The same precision optics, data processing techniques, and cryogenic systems that make Webb possible can lead to breakthroughs in medicine, communication, and energy. In chasing the origins of the universe, we often stumble upon tools that transform our world. The light Webb catches may be ancient, but the innovation it inspires is immediate. And beyond the technology lies something less tangible, but equally profound: perspective. To know that the universe may have formed and evolved in ways we never imagined is to confront the limits of human certainty. It humbles us, but it also ignites a deeper curiosity. We realize that the story of existence is still being written, and that we, fragile creatures on a small blue planet, are among its authors. If what Webb has uncovered is only the beginning, then the path ahead will take us into realms of possibility we have yet to name. With every new observation, the edges of our maps blur, and the boundary between the known and the unknown shifts. Somewhere in that shifting frontier, the answers may lie. Answers that could alter not only physics, but our understanding of reality itself. The telescope is more than a machine. It is a bridge, spanning billions of years, carrying our questions into the heart of the cosmos. Imagine what may still be hidden in its gaze. The birth cries of the first stars, the traces of forces we have never measured, the fingerprints of events that shaped everything we see today. Perhaps there are entirely new forms of matter, invisible threads weaving the universe together, waiting for us to notice. Or perhaps the most revolutionary truth will be that our current picture is only a fragment of a far larger, stranger whole. The Webb's mission is young, and its discoveries are already rewriting our textbooks. What will the next decade bring? As we stand here, on a small world orbiting an ordinary star, peering into a sky that has suddenly become more mysterious, one thing is certain. The universe has not yet revealed its final secret. And when it does, it will not simply confirm what we know. It will change who we are. For in seeking the cosmos, we are in truth seeking ourselves. Perhaps the greatest gift Webb has given us is not a single discovery, but the reminder that certainty is a fragile thing. For centuries, we have built a framework to explain the cosmos, confident in the elegance of its rules. Now, a silent sentinel far beyond the moon whispers that those rules may be incomplete. This is not the end of the story. It is the opening of a new chapter, one that will be written in the language of curiosity, doubt, and relentless pursuit. The universe is under no obligation to be simple, nor to fit neatly into our equations. It will continue to surprise us, to bend our expectations, and to challenge the boundaries of imagination. Webb's golden mirrors have shown us that reality is not a static truth to be memorized, but a living mystery to be experienced. And in that mystery lies the fuel for every question yet to be asked, every experiment yet to be conceived, every dream of reaching further than before. So, as this journey ends, we leave you not with answers, but with an invitation to look up at the night sky and feel the same wonder that drives scientists to risk careers and years in search of truths they may never fully hold. Because somewhere out there, in the depths beyond our sight, the universe is still speaking. And with Webb as our guide, we are learning, at last, to listen